There is no R. How would you get an R?
Let's talk about the esophagus.
It's got muscle, it's swallowing stuff.
Okay, now listen. The esophagus starts basically where your trachea starts, where it separates from the pharynx. The top part of the esophagus has skeletal muscle. The bottom part of the esophagus, down near where where it hooks into the stomach, has smooth muscle, and the middle part has both. And the muscle, of course, the whole point of it is to get the food into your stomach. Yes, right. Thank you.
It's very important.
The esophageal hiatus is the hole in the diaphragm, and that's important because basically that's the only real thing that kind of goes through all of your cavities, right? The pleural cavity, where you have the heart and the lungs, up here is pretty much separated from your abdominal cavity by the diaphragm. The only thing that runs through is that esophagus. So the esophageal hiatus is that opening where the esophagus goes through the diaphragm, as Riley said. Now, the esophagus is set up. Sorry, I'm going a little fast, I guess. So inside the esophagus, it's set up so that you have these epithelial tissues that run along the inside, and those epithelial tissues are very resistant to abrasion,
Fire.
hot and cold temperatures, and chemicals. And you probably noticed before that if you put something hot in your mouth, it feels really hot in your mouth, but once you finally get it swallowed down, you don't really feel it burning you, and that's because in the esophagus you've got that protection.
I feel like they can really hot because it swallows up.
Well, but I mean, it's kind of a good setup that here can't take as much heat as here. It'd be bad if it was the other setup. If you it was fine in your mouth, but you got it into the esophagus and it couldn't take it, you'd have damage all the time.
Is it like that your esophagus can take the heat, or does it just not feel it?
I think both. I'm sure there's not as many nerve endings there, but it's the tissue itself is very resistant to any types of damage. Okay, now as your food goes through your esophagus, it has to be lubricated. If it's completely dry, it's not moving through. Friction will cause it to get stuck. Okay, now the first part of that, of course, is in the oral cavity where the saliva helps lubricate it as you're breaking it down. But there is mucus and mucous membranes along the esophageal lining that is going to help lubricate things as they go down.
Water also helps.
It can, definitely can. Okay. So that's sort of the basic thing of the esophagus. Even though we swallow, remember, things have to go through the pharynx first. So your esophagus doesn't start till way down here, near where the epiglottis is. Now, at the top and the bottom of the esophagus, you have two bands of muscle called the esophageal, the upper and the lower esophageal sphincters, and those are going to help kind of control things moving in and out. But they're not going to really close things off like some of the other sphincter muscles that we'll talk about before. And that's because involuntary actions like swallowing and puking are going to be able to move things through those bands of muscle. Speaking of swallowing, let's talk about that. Okay, the technical term for swallowing, I believe, is pronounced deglutition. And then I couldn't say it. Deglutition follows three basic kind of steps, starting with the oral phase. So in the oral phase, the tongue pushes the stuff towards the hard palate, and then your involuntary responses will take over. Your tongue is going to kind of pull back. The soft palate is going to move up and try to block things from going up your nose. Of course, that doesn't always work. Sometimes things get stuck up there if you cough or laugh or something as you're trying to eat. Milk can come out, yes. And then the skeletal muscle up here in the pharynx is going to help squeeze and contract, and things are going to get dumped down the pharynx towards the esophagus. Okay, now the chunk that is being swallowed, we call that a bolus. So that's you can think of it as just kind of the chunk of stuff, however big it is. And of course, the smaller bolus is better. That's why parents tell you to chew your food before you swallow, because it's less likely to get stuck. Now, in your pharynx, there's sensory receptors, stretch receptors, that are going to recognize, hey, there's this big thing here. And then the involuntary actions, the skeletal or the smooth muscle is going to take over and start to push that thing down the esophagus, or down the pharynx towards the esophagus and towards the stomach. Okay, and so that part is called the pharyngeal or pharyngeal phase, where it's in the pharynx. So each of these phases of swallowing is named after the part, the area where it's happening. So the oral, the pharyngeal, and then the esophageal is where it's actually going through the esophagus. Okay. Now we've already talked about peristalsis, and then there's going to be peristalsis of the smooth muscles through the esophagus to push that stuff down through and get into your stomach. If you've ever accidentally swallowed something a little bit too big and getting that stuck in there, you can feel those muscles kind of working, trying to pull it down. It's an involuntary action here. I mean, you may be trying to swallow to kind of help things, but in that area of the esophagus, your body is doing it. The stretch receptors are saying, hey, we need to force this thing down and through. You can kind of feel that working and feel that thing slowly moving down as it gets stuck. Yes?
So what's that weird feeling like when you take too big of a gulp of water?
Too big of a gulp of water?
Yeah, like I'll be drinking a liquid and all of a sudden I feel like I got to put my ass just down. Chew it.
I'm going to go with cancer.
Right.
I don't know. That's not something that I've experienced. So.
I've never taken a drink and like felt like a ball to be or anything.
Yeah.
I do that a lot.
I don't know. Sorry. I have no experience nor any information on that.
Why does sometimes
I don't know.
when you drink some water, it feels cold coming down your throat, like down your esophagus? It's cold. They sit there no.
No, there's nerve endings there. It's resistant to damage, but there's still nerve endings. Resistant doesn't mean unfeeling.
Like you might be able to resist the energy, but it doesn't feel
Okay, so most swallowing, the bolus takes about 9 seconds to get from your mouth down through your esophagus, which, if you think about it, it's sort of a long time.
I thought it was 15.
I don't think you're right.
I read the book.
The book says that.
Yeah, right here it does. So, but if you actually count out 9 seconds,
Then it takes slower because you can't know the position or the velocity at the same time.
okay, great,
It's like an
Eric.
electron.
I'm saying if you count out 9 seconds, I think it'll seem like a long amount of time, and it kind of is. So most of the actual swallowing thing we probably don't notice. Once it's down into our esophagus, as long as it's not some big thing that's stuck that's giving us discomfort, we don't notice the rest of that esophageal phase. Liquids, of course, are going to go down much easier because they don't have to be pushed along. And I think that's pretty much all we need to know about the esophagus and swallowing. So, the stomach. The stomach has a few functions. Obvious one, storage of food. But it's also going to start the chemical breakdown and help to kind of finish up the mechanical breakdown of that food. So there is actual churning that happens in your stomach and mixing of contents, and there's some strong muscles, smooth muscles there, that actually help to kind of break the things up into smaller pieces. But the stomach also does excrete something called intrinsic factor that is important in the uptake of vitamin B12. So the bile is actually going to be more of a factor of the chemical breakdown of the actual substance.
So helps with vitamin B.
B12.
With the enzyme.
Yes. So, in your stomach, we know there's acid that is produced. We'll talk about the acid production, the hydrochloric acid production by the specific cells in the stomach in a little bit. But that mix of acid and enzymes is called chyme. C-H-Y-M-E.
So the bile.
Bile. Same thing. Okay, now your stomach, we usually divide into four main parts. There's the cardia, the fundus, the body, and the pylorus. And I would look on page 496 to see those different parts. So it is kind of just a big sac, but the cardia is basically where the esophagus comes in. The fundus is just kind of a big bulge on the one side. The main part of it is the body. And then the pylorus is where the stomach empties into the intestines. And there's going to be a big sphincter, a big round muscle at the end of that called the pyloric sphincter, which is going to be important in basically letting stuff through into the intestines and determining how much stuff is in the stomach and how much gets moved on. Okay, now the stomach is kind of like a big sack. It is able to expand quite a bit. When it is kind of empty, it's going to be folded up and kind of shriveled. And it's going to have these ridges called rugae in it that look like wrinkles. It'll kind of look like a piece of paper folded up like this. As more and more contents get put into the stomach is going to expand, and those rugae will smooth out. They won't really be there anymore. So it just is a way of having a big kind of rigid wall that will keep things in, but have it able to fold up and create a smaller thing that can change size.
I have some better stretching.
You have big rugae, your stomach is empty. Yes, that's what you're telling me.
Okay.
Okay. Your stomach's empty. And I guess the other thing I know about the structure of the stomach is that there's a lot of muscle, a lot of smooth muscle there. We won't worry about the actual bands and how they're distributed, but you have to have big muscles around the stomach because it does churn and mix things. It's not like it just sits there like a sac. It is a muscular sac. It's able to knead and break up contents inside your stomach. Now in the wall of your stomach, you have gastric pits. So they're basically these think about almost like when we looked at the structure of a hair, the hair shaft as it runs down into the skin, that's what these gastric pits are like. But instead of having a hair sticking out of them, down in the bottom of those gastric pits, you have gastric glands. Those gastric glands are going to be what produce the gastric juice, which is the mixture of stuff that is going to become the chyme. Gastric juice is going to be created by two different types of cells, the parietal and the chief cells. And we'll look at those each in a minute. But as it says in the book, you get about 1,500 milliliters, so about 1.5 liters of gastric juice produced every single day, which is a lot. Now, on the way through your intestines, a lot of the components of that gastric juice will be reabsorbed and used, but the rest of it, of course, will move out in the eventuality that is defecation. So in the gastric glands, you got parietal cells and chief cells. Parietal cells are going to secrete the intrinsic factor that's important for the B12 pickup, but also the hydrochloric acid. And the hydrochloric acid is going to have a couple functions. It's going to help kill microorganisms. So when you ingest things, most of the stuff that you take in is going to have some sort of bacteria or viruses in it. And a lot of that can be taken out without your body's lymphatic systems or immune system being involved, just by destroying it by this acidic environment in the stomach. But the acidic environment is also going to help break down certain chemicals in the food as well. The chief cells are going to secrete the pepsinogen, which is going to get converted by the hydrochloric acid into pepsin. So that's kind of another feature of the hydrochloric acid, is that it activates this pepsinogen to turn into pepsin, which is an important enzyme, especially for breaking down proteins.
Like rice.
No, it's not like rice. So proteins tend to be the hardest things for your body to break apart. So that pepsin is an important enzyme for doing that.
So the chief cells do pepsinogen.
Pepsinogen, which the hydrochloric acid turns into pepsin. So it's just, it's, and they sort of, I mean, they produce the pepsin, but they produce it in a unactivated form, and it takes the hydrochloric acid to activate it. Okay.
So all the salt that we eat gets turned to water and then reduce the sodium for like food.
Some of it. Yeah, some of it gets incorporated. What's that? I would imagine some of that gets turned into the hydrochloric acid. So yeah, salt is an important part of your diet, but people take in way too much. It's way more than they actually need. So, as far as your stomach goes and the secretions of these gastric juices, there's 3 stages that go along with that. So first you got the cephalic phase. That's going to happen when you first smell or look at food. Could be. So when you first smell or look at food, your brain is going to go, huh, food. I need that in my belly. And so your stomach is going to start secreting those gastric juices and prepare your stomach for retrieving that food, retaining it. When the food actually gets into your stomach, the gastric phase starts. Stretch receptors in your stomach are going to go, hey, this thing's getting full. We should start doing something about that. And it'll start secreting lots of hormones and enzymes to help break that food down. Also, during the gastric phase, you're going to have those muscular contractions of the stomach to knead the food up. Okay, once the gastric phase is over, the chyme will move on to the intestines, so that starts the intestinal phase. And in the intestine, all sorts of hormones are going to be released, and that's where, in the small intestine, you're going to get the major absorption of those nutrients. So the stomach is more for, it does absorb a little bit, but it's more for getting things ready to be absorbed, breaking them down, making sure the intestines get things in a condition that they're able to uptake most of the nutrients. The stomach is not very good at uptaking nutrients because it's got a big mucus layer. It's hard for stuff to get pulled up from there, to get absorbed by the epithelial cells. Huh? Fairly easy. Oh, it's lazy. No, it's just not set up for it. Okay, great, Eric. It's all... Do you know how hard it is to keep my mind going when I have you two idiots in class? Also, the epithelial cells don't have the mechanisms that are needed to be good at taking nutrients and transferring those into the bloodstream. So what I'm getting at is the stomach is not great at absorbing. It's good at breaking things down and getting them ready to absorb. That's all I have to say about